Good morning, dear students. I am Dr. Srinivas Bhattini, Professor of Chemistry in St. Peter's Engineering College. In the last class, we have discussed the introduction of fourth unit, that is about fuels and combustion, and classification, and stable or unstable molecules. So all this we have discussed in the last video. And the characteristics also we have discussed in one of the video. Characteristics, efficiency, like that we have discussed. And now in the classification we have seen solid fuels and liquid fuels in the classifications. Okay, that is in the last video. Solid fuels, liquid fuels and gaseous fuels we have seen, we have discussed in the last video. Okay, now today I am going to discuss about the solid fuels. What is the topic today? Solid fuels. Solid fuels. Solid fuels, how it forms on the earth? The question. How it forms on the earth? How it forms? We know that tsunamis and earthquake occurs frequently. Earthquake, tsunami. So as a result, we lost our lives, buildings, or many things we lost. And forests like trees were buried inside the earth. By the action of temperature and pressure and bacterial action, for thousands of years, when buried the tree beneath the earth, the pressure is increased, the temperature is increased, and the action of bacterial action. For thousands of years, they were converted into brown color, brown, black, solid, named coal. Thousands of years, trees buried when earthquake occurs, high temperature, pressure and bacterial action. So then the trees converted into coal. The trees were buried on the earth when tsunami occurred or earthquake occurred. The trees converted into coal when at high temperature, pressure, by the action of bacteria. So simply, wood converted into coal. That is at high temperature and pressure by bacterial action. At high temperature and pressure, the wood is converted into coal by the action of bacteria. Okay? Since wood contains high carbon percentage, wood contains the high percentage of carbon in the form of cellulose. Wood containing the what? Cellulose or lignocellulose. We know the formula of cellulose. That is, this is the structure of cellulose. We know glucose, fructose means C6H12, O6 is the glucose, and cellulose means many, it's a polymer. many glucose molecules attached together. That is called the cellulose. Cycle. It is a cycle. It is in a cycle. It is a cycle. Polymer. Cellulose means a polymer of glucose molecule. A lignocellulose. Which one? The wood containing the cellulose and lignocellulose. Mean that is the mean. Here the carbon is present. C6H12O6. What are the elements are present? Carbon, hydrogen and oxygen is present in the wood. The wood containing the carbon, hydrogen and oxygen. They are transformed in the form of coal. So here the cellulose and ignose form the coal. Coal is what? Only carbon. Only carbon. So the process of conversion of wood into coal is called what? Qualification. The process of conversion of wood into coal is called the qualification. Qualification. Qualification means the process of conversion of wood into coal is called the qualification. So depending upon the percentage of carbon, hydrogen and oxygen and moisture and calorific value. So we have to give the rank. The 4 different types of coals exist is called the ranking of coal. What is the ranking of coal? Ranking of coal. So ranking of coal mean what? The process of conversion of wood into coal is called the qualification. That is depending upon the percentage of carbon, hydrogen and moisture and calorific value. There are 4 types of coals exist is called the ranking. Is called the ranking. So ranking, we know the word is the ranking. The second word is the qualification. The 2 words we have now. What is that? Qualification and ranking of coal. So before going to the classification, we have to know that how much percentage is present in the coal. The dry wood contains how much of carbon, how much of oxygen, how much of hydrogen. We have to know, that is important. Okay, before going to classify the solid coal, we have to know about what is the percentage of carbon, hydrogen in dry wood. That must be, we have to know. So what is that? The percentage of carbon, hydrogen and oxygen in dry wood. So dry wood contains what is the percentage of carbon? There is a 40 to 50 percentage of carbon. How much percent is present in dry wood? The 40 to 50 percentage. And what about the oxygen? That is 40 to 50 percentage oxygen. And hydrogen 5 to 6 percent. Why? Almost the carbon and oxygen almost equal. Example, we know that glucose containing the formula, what is the formula? C6H12O6. So 6 carbons and 6 oxygens. Almost the equal amount is present in dry wood. Hydrogen is less percentage compared to the molecular weight, number of hydrogen atoms and the molecular weight. Okay, that is we have to calculate. So almost carbon and hydrogen equal amount. Okay, now cellulose also, it's a polymer of glucose molecules, okay, or fructose molecules. Here we have to see that the percentage of carbon, we know the 40 to 50% is carbon and 40, oxygen, 40 to 50 oxygen, 40 to 50% oxygen, and hydrogen is 5 to 6%. And what is the calorific value of wood? The wood calorific value is how much? Calorific value is 4000 to 4500 kilocalories per kilograms. 4000 to 4. So what is meant by calorific value? So we will discuss another video separate a calorific value. What is calorific value and what are the units we will discuss in the separate class. Just we have to know the calorific value 4000 to 4500. Okay. Wood can be converted into charcoal by that is carbonization. So what is that? Wood can be converted, the dry wood can be converted into charcoal. That is what we have to start, synthetic charcoal. So the dry wood can be converted to wood to charcoal is called the carbonization. So what is meant by carbonation? What is carbonization? So it is simply, what is that? The destructive distillation of wood. Destructive distillation of wood. Destructive distillation of wood. What is meant by destructive distillation of? In a reactor, in a big reactor, we have to control all the wood pieces. Small wood pieces. This is the reactor, a big reactor. So we have to give the heat energy and pressure developed inside. Under high pressure and heat, we have to distill the water, remove the water. Under pressure, the wood is converted into charcoal. The charcoal, what is the importance of charcoal? Many uses are there. In the sugar industry, the white sugar is in the white color because of we are using the charcoal. Actually, the sugar cane, the yellow color juice will come, and yellow color crystals will come. Dissolve the yellow color crystals in water and add the charcoal and heat well and remove the charcoal, filter it, then white color crystallization takes place. That is the white color crystals is called the sugar, because the reason is only charcoal. The charcoal is prepared from where? Wood. By the process is called carbonization. What is the process? Destructive distillation of wood. This is the destructive distillation. The black color. Because the reason it is absorb the colors. The charcoal is used as an absorbent. We can say charcoal is an absorbent. So this is the what? Charcoal is used in absorbent of gases for decolorization. We can say decolorization of sugar or decolorization of any compounds in synthetic chemistry. We have to know that decolorization. Okay, that is about the simple, the percentage of carbon present in the wood. Okay, now we will discuss about the classification of coal by ranking. Classification of coal by ranking. So what is the classification? The coal. We know the coal is only black color, a cake, a solid cake we have seen in the Singarini industry, especially in Adilabad district, Warangal district, the Bellampalli containing the Singer and mines, we have seen black color. Okay, but in Hyderabad that is none there. In Khammam district also there, Warangal districts. The coal mines are many in Telangana. Okay, the black color. So we know the only one black color, that is coal, but many types are there. That is today we are to discuss about that. What is that? The various types of coals are commonly recognized based on degree of alternation or qualification from the parent material. Parent material is what? Wood. Wood is a parent material. From the wood, many types of coal. The progressive transformation of wood to anthracite. What is the progress? From parent wood is the wood. So wood converted into some peat, then lignite. Lignite coming from the lignocellulose, and bituminous, and finally anthracite. So this many, wood we know and anthracite we know, but this one, peat, lignite, bituminous, so these are. So various types of coal based on the ranking. What ranking? What is peat? What is lignite? What is bituminous? And what is anthracite? We have to look. So peat we have to see. Peat is brown fibrous jelly-like mass, which is generated the first stage of the qualification of wood. The first stage. First stage means then wood is converted under pressure and bacterial action, under heat and pressure. First part is the peat, is generated first stage. It may contain as much of 80 to 90% is of water. Here how much percentage is there? 80 to 90% of water. We can write this one. Wood, peat, lignite, bituminous, anthracite. Okay, now we have to see this one, peat. So peat is how much percent? 80 to 90% of water. How much? 80 to 90% is water. 80 to 90% of water. But on air drying means you have to remove the peat and dry in the open places after 1-2 months. So then it burns freely. It is freely. It is not economical because of the very high percentage of water. Almost 80 to 90% is of water at present. It's not economical because the very high percentage of water content. The average composition of air dried peat is almost 57% of carbon. 57% is carbon. Hydrogen is 6%. And oxygen is 35%. Oxygen is 35% in the peat. So 2.5 to 6% is that much hydrogen. Okay. And what is the calorific value of this one? Almost its calorific value is 54,000 kilocalories. 5,400 kilocalories per kilograms. Its calorific value. Next, lignite. This is soft brown colored verified by lowest rank coals. It is the lowest rank. It is the lowest rank coals, which consist of vegetable matter decomposed more than the peat. Lignite compact in texture, containing 20 to 70% moisture. Here the 20 to 70% moisture. Water, we can say water. Here the 80 to 90% is water. Okay. On air drying, it breaks up into small pieces. Air dry lignite contains the 60 to 70%. After air drying, how much percent is there? 60 to 70%. 60 to 70% is carbon. Okay? 60 to 70%. And oxygen is the 20%. Oxygen. So lignite burns with a long smoky flame. Lignite burns with a long smoky flame. The calorific value of this one, 6,500 to 7,100 kilocalories per kgs. On the air dry basis, lignite used as a household fuel. We can use this one, household fuel. We can use in the house. It is also used in the manufacture of producer gas. We can use this one for producer gas also. Producer gas. In industry, we can use the producer gas. Next, bituminous. Bituminous is called the commercial coal. We can say bituminous, we can call the common coal. Common coal. There are pitch black to dark grey color. They show a constructed structure of alternate, very bright and dull layers. The bituminous coals are classified based on that carbon percentage. They are the sub-bituminous, bituminous and semi-bituminous. Here that bituminous, bituminous, sub-bituminous, bituminous and semi-bituminous. Bituminous. Okay? Bituminous. Sub-bituminous, bituminous and semi-bituminous. Okay. What is meant by sub-bituminous? Sub-bituminous coals are black and more homogeneous and smooth in appearance. Sub-bituminous. And carbon content varies of 75 to 83% with calorific value 7,000. Hear that? 7,000 calorific value. Very smooth in nature. Sub-bituminous. 7,000 kilocalorie and smooth and 75 to 83% of calorific value. Their moisture and volatile contents are high on exposure in air, and these crumble into small pieces. We can use that one. Small pieces. Okay? Bituminous coal shows a typical banded appearance and content of ranges of 78 to 90%. Bituminous is the 78 to 90%, 90%. 78 to 90%, and volatile matter is 20% to 48%. Their calorific value is almost 8,000. Bituminous is the 8,000. So coal of this class is used in the large quantities in industries for making metallurgical coal gas for steam raising. We can use the steam raising and bituminous. And semi-bituminous are rich in carbon, 92%, 95% is, we can say 90% is above in low value, low volatile matter. These are used for the Coke manufacture, the calorific value is a high calorific, almost 8,500 kilocalories. Kilocalories or kilograms. And last one is the anthracite. Anthracite. What is the anthracite? So this is the last one. It is the highest rank of coal containing a higher percentage, almost 92. This one is the 98 percentage. 98 percentage of coal. And as the lowest volatile matter. In this only volatile matter is very much, the moisture is very low content. Because of low volatile matter content, they ignite with the difficult, but burn without any smoke. Without any smoke. No smoke, it burns very clear. It gives intense local heating. These are the hardest kind of coal. That coal is a very first rank. Anthracite is the very good coal, first rank. The calorific value is almost 8,650, 87,000. How much calorific value? 8,700 kilocalories per kilograms. And ash content is very low, about 3% ash content. There is no ash. Only 3% is completely burned and give a lot of energy. They are used for steam raising, for household purpose and metallurgical process, where no smoke and high local heat are desired. So among all these things, so which one is very good? Anthracite. Next is the bituminous. In the bituminous is very good. Okay, so today what we have discussed, that classification of coal, solid fuels, the classification of coal by ranking, carbonization and everything. Okay, thank you very much.